Alright, so dados and grooves are essentially exactly the same thing. The difference is a dado is a rectangular recess cut across the grain of the board. So here's the grain, the length of the board, we're coming across. Again, could be cabinet construction used to assemble the tops and bottoms into the side. Could be used for shelf construction. Something's going to be inserted into that dado. It's a very strong joint. A lot of contact area, has a locking mechanism, usually vertically, obviously can be depending on the orientation of your project, locking mechanism horizontally depending on the orientation of the project. So this thickness here, a standard dado, is generally half the thickness of the material, so it usually go back in this direction, 3/8 of an inch. And then the width of it, standard, is 3/4. Okay, so it depends on what you're doing. Those are just typical working with standard dimensional stock that is 3/4 of an inch. So if this is 3/4, you're going to go half the depth, which would be 3/8. And then the thickness of the stock that's going to be plugged in there is generally 3/4. Now that can vary greatly depending on what type of stock you're working with. Obviously, if you're working with 1/2 inch stock, that's going to be a 1/4 inch, and this is going to be a 1/2. So it just depends on the stock that you're working with, but generally speaking, those are the dimensional values that exist for a dado cut across the grain. Okay? On the other end of the spectrum, the groove, once again, it's the exact same thing, only the groove is cut the length of the board. Okay, so a rectangular recess cut with the grain. So again, our grain is running in this direction with the grain of the board, or the wood, either one, on the surface or edge of the board. So I have this one drawn on the surface of the board. Once again, this could be like the back of a project where you're sliding in a piece of backing. Could be a series of different things. It could be a groove cut to hold a piece of glass or backing or whatever that may be. We also can cut a groove on the edge of the board, where you guys have probably seen that mostly used in flooring construction with the tongue and groove, where you're cutting a groove that's going to receive the tongue of the flooring, which we haven't went over tongue and groove joints, but obviously the groove is one of the aspects of a combination of two joints. Does that make sense? Okay, so that's the overview of it. All right, so first thing we're going to cut on here is we're going to go ahead and cut the grooves in the board. So, cut a groove on the table saw. You can do it in multiple different ways. If you have a standard blade on here, you're cutting a groove in the board, you're definitely going to have to make multiple passes, because this blade's only 1/8 of an inch long. Okay, so if you're making a small project that doesn't require too many grooves, it's sufficient to do it on the table saw. But if you're making something that has multiple grooves in it, you do not want to use the table saw. You probably want to use the router bit or a dado blade, which I'm going to do that here momentarily as well. That's going to get this done in one pass instead of multiple passes. So the first thing we need to do is find the center of the stock. So I'm going to mark this with a marker, even though it's not as accurate, just for the fact of not only the video, but you guys being able to see. So once again, generally with our grooves or dados, we want the blade or the groove to be cut halfway through the material. That's how I'm going to determine the height in which I set the blade. So I'm going to drop the blade down, so it's coming halfway through the material. And then I'm going to figure out wherever I want my groove at. So I'm just doing this based on demonstration. So I'm going to have it about a 1/2 inch off the back edge. And I'm just going to cut this groove. So what we want to do is, we always, when making a groove or anything like this on the table saw, if I'm doing it on the surface, I want to always be moving the fence away from the blade. Okay? So I'm going to start with my closest pass with the fence closest to the blade, and then gradually move the fence away from the blade so there's no chance of me moving the blade back in, or the fence back into the blade. Make sense? So, once again, all I'm going to do here is make a pass across this. So technically that's a groove. It's a curve cut in the board. Obviously, unless I have an 1/8" piece of stock that's going in there, which if you could have an 1/8" piece of backing that would fit down in there, that could work for a groove. Generally, it's going to be a little bit wider than that. Once again, if we're going wider than that, we're then going to tap the blade out. We don't want to go more than 1/8 inch. If we go more than 1/8 inch, we're going to have a remaining piece of material left there that's not going to be cleaned out. Okay, so if you're wanting to fit a 1/4 inch piece of stock or something like that in here, it's probably actually going to take you 3 passes, with the last pass being very minimal because we want to overlap that 1/8 inch kerf every single time. Okay, so we're just going to lock that down. Again, I tap the fence away from the blade. Once again, rectangular recess, cut the length of the board, creating a groove in there. That would be sufficient. That's about a 1/4 inch. So if I was taking a piece of backing or something and getting in there, that would work as the groove for that. Make sense? So that's the groove on the surface. The next thing you want to do is, if you were putting a groove in the edge of the board, you're going to measure and find the center of the board. Once again, and this is a double pass process, and you'll understand what I mean by that here momentarily. So I'm going to find the center of the board. Once again, it's 3/4. I'm going to try to get to 3/8 inch. It's impossible for me to set this at dead center. So what I'm going to do is I'm going to bring my fence over. I'm going to line that up with that line that I just made, knowing that I'm not in dead center. But I need my kerf or my groove cut in the edge of this board to be dead center. So how I'm going to make it become dead center, I'm going to make this cut. Now before I make any adjustments, I'm going to rotate it 180 degrees, and whatever I was off, now we'll do a double cut and make sure that it's right down dead center of the board. Okay? Again, I'm going to tap the fence away from the board, the fence away from the blade, making sure I'm not moving it back into the blade. What you have to be aware of when you're doing this is that every pass that you make is magnified, because you're taking off twice as much, because you got to do it one pass, rotate it 180 degrees, and take that another pass. So if I'm moving the fence to 16th to keep the kerf in the center, I'm actually taking off 1/8 of an inch because I got to do a double pass. Make sense? Now, this would be an example of a tongue and groove. Generally, a tongue and groove where it's going to receive another piece of wood, I'd have to make one more pass for this to fit. And actually, no, I don't. It's pretty tight in there. Okay, so this would be the tongue of another board getting inserted in there. Generally, on hardwood flooring or something like that, if you're making a tongue and groove, your inside groove is going to be 3/8 of an inch, and you'll have 3/16 shoulders left over on each side. Again, you can implement that however you want. A lot of times, depending on what you have available, so a lot of the doors and stuff that we make in here, we use router sets that are made to match each other to make our stiles and rails. If you did not have that available, you could very easily make a paneled door by putting a groove, which is going to receive the panel, and then cut a tongue on your rail that's going to insert into that, and it would work just as efficient. And you could do that essentially on the table saw. You would need the use of the 10-inch jig to make the tongue that's going to insert into that groove. Okay, but right now we're talking about dados and grooves. And so far I've made a groove on the edge of the board using the table saw and a groove on the surface of the board using the table saw. Okay? We can also make a dado on the table saw utilizing the miter gauge slot. If we're going to do this and we're going to make multiple dados on the table saw, what you would want to do is use your fence as a stop block. Determine, once again, if you're doing this first pass with the scrap piece to make sure you're getting the correct shoulder width. Once you've determined that, you've got the blade once again raised halfway through the stock. We set the blade, it's already set there based on the groove that I made earlier. The only difference is I'm using the miter gauge to cross cut with, and I'm going across the grain instead of with the grain. So I'm going to leave this here. Once again, I cannot use these in combination with one another, so I'm going to leave this spacer behind when I cut that shoulder in there for the groove dado. So if I was doing multiple boards that received this, I would have every single one that I have and make that first pass on there once I knew it was true. Okay? From that point forward, I would gradually tap the blade away until I get to my other side of my dado, but only on my first board. Okay? So once again, to represent that, I'm going to cut a dado on the other edge of this board to show you what I'm talking about and what it looks like. So right there I have my first pass on both ends of the board, right? With the exact same distance off the edge. It should be. And now I'm going to finish up with my first one and stop at the thickness that I desire. So once again, I'm going to barely tap the fence away from the blade, making it until I get to my desired width. Now if that's my desired width, to ensure that I have the exact width on my opposing dado, now I'm going to come up and I'm going to cut that last cut on that dado. Alright, so that's how you cut a dado on the table saw. We cut a groove in the surface, a groove in the edge, and dados on the table. Look, when making the dado on here, same thing. We're going to come down, we're going to measure halfway through the material to determine the height of our blade that we're going to make. So I'm going to measure down 3/8. In this situation, I'm going to measure 3/8 over, and then to 3/4. So here, this is basically the reverse of the table saw. So instead of dropping the blade down, I'm raising the blade up. So it's only coming halfway through the stock. What you got to make sure is you pull your blade out far enough. You guys getting this? Pulling your blade out far enough that it's only cutting halfway through the material. You got to get to the bottom dead center on that. Again, what I'm going to do at this point, I'm going to make my first cut on all my pieces, exact depth off the fence. So, this is going to be my first pass on my dado, so however many I was cutting, I do this repetitively. Halfway through the material. Now I'm going to clean up this inside. Once I determine how wide I need my dado to be, I'm then going to reset the stop block. That final cut, rotate it around. By doing it in this fashion, I have the exact same distance off the edge here and here, and the exact same distance off for the width of the dado here and here for every single one. Now all I need to do is go back and clean up the remaining material that exists on the dado. So in that situation, I would remove the stop block. Now I have the exact same dados cut on each end of the board. Once again, we have to make sure that we're pulling the blade out at least the radius of the blade, or you're going to end up with a sloped surface in here taking the profile of the blade. So you got to pull out at least the bottom dead center of that tooth, or you're not cutting to maximum depth. So again, this would be beneficial if I'm making maybe one project. If I'm making repetitive things and need multiple of these dados cut, probably a little bit more efficient way to do it, okay? But it can be done here. All right, same exact thing that we've done over and over again. The dado composition has not changed. We're gonna come up halfway through the material, 3/8 of an inch. However far off the edge we want to start the dado. And that's going to determine how we set the saw up. So in this situation, my first mark here, my horizontal mark, I'm going to raise the blade up. It's already set there to halfway through the material. Now, just so you guys can see a little bit better with the video here, I'm only cutting one of these, but if I wasn't cutting one, I'd pull this fence into here and use a separate piece as a stop block, much like I did on the other table saw, so I can get the exact same cut every single time. This is actually referred to as a wobble dado blade, which is kind of, it looks kind of scary to use it. The blade is basically wobbling on purpose to create a 3/4 inch dado in one pass, expediting the process, okay? There's also what is called a stack dado, which if anybody starts cutting multiple dados in here, that's what I'll put in here. That's multiple blades stacked right next to each other. So every time you add a blade, you add 1/8 of an inch, and it's a wide blade making one pass, okay? Same exact thing, just different blades. So now I'm gonna come up, I'm gonna say this is the shoulder of my dado, right there. One pass, I'm gonna cut a dado, a rectangular recess across the board. You see it wobbling, right? essentially taking 6 passes to cut that dado, right? I was able to do it in 1 pass, okay? Next thing, we're gonna cut a groove. Same exact process, but we're gonna use the rip fin. Completely consumed inside the board here, so technically there's very little chance of getting cut, except for where the blade exits the back of the board. So obviously we need to be cognizant of that. Safety margin is still 4 inches. Cut through the surface of the board. Rectangular recess, cut the length of the board. Obviously I could do this on the edge as well. If I change the setting of the wobble, I can actually get in there, take that blade out, and rotate it so it alters how far it wobbles. And I can go from 1/8 of an inch up to 3/4 of an inch dado with this blade. Or if I'm using the stacked dado, once again, however many boards or blades I would stack upon one another would control the width of the dado or the kerf being cut as I'm making that cut. Make sense? So you can see how this would definitely expedite the process, 1 cut and done versus multiple cuts. Kind of depends on what you have available and what you have set up for your project, and actually how many are going to be done. So if you're going to do a multitude of dados, you might want to take the time to go ahead and set the dado blade up to cut the dado, so you're doing it in 1 pass. But if you only got to cut a couple of them, sometimes it's just as quick and as efficient to do a multiple pass on either the table saw or the radial arm saw. All right, so the table router. What we know about the table router is we always cut from right to left, correct? Once again, we can cut a groove on here, we can cut a dado on here. We're going to cut both of them on here. A dado would be determined based on the width of stock that you need. That would be determined based on the bit diameter that you would get. So right now I have a 1/4 inch groove bit in there. I could have an 3/8 groove bit. I could have a 1/2 inch groove bit. I could have a 3/4. And once again, it's going to be usually a two pass process when using the router bit, because we know that the maximum amount of material we can take off, how far the bit is coming into the board. Each pass is a 1/4 of an inch. So to be able to get to that 3/8 general depth, we're going to have to do that in 2 passes to get our first pass cleaned out, and then to go to our actual desired depth, we'd have to raise the bit up a little bit. Okay? So, once again, this is just going to be a cross cut here. Now, I'm actually not going to come all the way against the fence here just for demonstration. You can cut with the miter gauge and the fence on the router. You just got to take it slow. Rectangular recess, cut across the grain of the wood, a dado. Once again, the dado is going to be controlled by the diameter of the router bit that you have in there, some form of straight groove. I did this intentionally. I don't know if you can see this or not, but the back side of that board chips out when I cut that dado. Anytime you're using a router or coming across the grain on a board, you generally want to have some type of scrap piece of wood behind the board. You need something longer than this to use as a backup to reinforce that to keep it from splintering out. Does that make sense? Doesn't happen when you're going the length of the board with the grain, but when you're going across, you're cutting cross grain, so it's going to want to tear out. Okay? So that's how I would cut the dado in there. I can also cut a groove by utilizing the fence. Same thing, just keep the board up against the fence. So again, the bit is going to exit the back side of this, so that's where you got to be worried about it getting cut. There's a groove, a rectangular recess cut on the surface of the board. Make sense? We can also cut that on the edge by just moving our fence over. Now, obviously, if this was not a demonstration, I would be measuring and marking the exact center. I'm just showing you how to cut it here, but we want this dead center in there. Cutting straight down the middle of it. You'd want to do that with a practice piece to ensure that you have it exactly centered before cutting. Rectangular recess cut across the edge of the board. Now here's what you want to be aware of anytime you're cutting a groove bit like this, and why we want to make sure that we're not taking off too much material and having the bit too far out of the table, is because you guys know how those bits go in there. They're tightened and pressed in there with a collet. If you put too much load or stress on that bit, it'll start to slip and be pulled up out of that collet and will vary the thickness of your dado, and if you're going through the surface, could ultimately come up and come through the surface of the board. What's on the surface of the board? Your hands are. Okay, so that's why we want to make sure we're not overloading the capacity of the bit. We have our collet nice and tight on our bit. And once again, we're not trying to take off too much material. We're doing it in the adequate number of passes, not trying to take off too much material to expedite it, which will jeopardize safety. Make sense? Multiple ways I showed you to cut grooves and dados. Once again, dado is a rectangular recess cut across the grain, where a groove is a rectangular recess cut with the grain on the surface or the edge of the board.